No. All right. Okay. So I wanted to recap this right here. So using our chart, if we are looking for the right of 1.23, our answer, and then do we need to do anything with that answer? If I'm looking for the right, yes, I need to subtract it by 1. So I need to do 1 minus what is 1.23's area? And therefore I get perfect. And then that is your area under the curve. If I'm looking to the left of something, when I go find this area, am I going to have to do anything with it? No. So what's the answer? 15, 15. If I'm looking between negative 2.15 and 0.97, how would I find out the area of this guy? Very good. So you want to subtract the it's really the right side from the left side. So what's the 0.97 here? So 0.8340 minus what's the area at negative 2.15? 0.158. And when you subtract the 2, what do you get? Absolutely. Yeah, I mean, it sure is. There you go, Rivers. All right, so any questions on what we talked about yesterday of finding the area under the curve using the z-score? We're pretty solid on how to find the answers with that chart. All right, perfect. All right, so let's look at example 2 here, which now we're going to look for the probabilities for regions between values. So we want to find the probability using the standard normal distribution curve. And we want to find the probability of getting something between 0, which is the mean, and 0.92, which is a little less than the standard deviation. The best way to do this is you just, to do the less than here, you just got to try to find out the area between these two numbers. You're trying to find the probability that it will be between these two numbers. You just got to find the area between the two numbers. So what is the area of 0.92? So if you're trying to find the probability that your data will fall between 0 and 0.92 of a z-score, you got to find out what that area of data is. So to do that, you would just take 0.92 minus 0.5, which is what the mean is, and then that would give you the probability of the area underneath. Because the probability has to be less than 1, the area under the curve is also less than 1. So 0.92 is what? 8212 minus the 0.5 for the mean or the average, which is right there in half. And what do you get? Perfect. So that is your probability. You have a 32% chance of finding some of your data that will be between 0 and 0.92. So it's the same math, a different way to ask the same question though. Right? So the area is the same thing as your probability. Questions? All right. So if I want to find something where the z-score will be less than 2.7, I'm looking for something that's left of 2.77. So when I go find the area for 2.77, do I need to do anything with it? No. So what's the answer? So again, what you're basically stating here, you have a 99.72% chance of finding data that will have a z-score of less than 2.77. Does that make a little bit more sense now? Okay. So now I want something greater than 1.12. So I'm looking to the right of 1.12. So what am I have to do with the area once I find 1.12? Okay, so what is 1 minus the area of 1.12? 8666. 8686. So therefore, you have a 13.14% chance of being greater than 1.12 standard deviations away from the mean. Again, I have something in between, so I'm just going to subtract the two. So what is the area of 1.56? 0.9406 minus what's the area of negative 1.20? 1151. And when you subtract the two, what do you get? Close. 8255. Right. So again, you have an 82.55% chance that whatever your data is will fall between negative 1.2 standard deviations and 1.56 standard deviations from your mean. Questions on probability? All right, let's look. Sure, if you still got questions on previous probabilities. Okay. I did y'all's grades from the homework I did last night. So you can look at that to see if it changed your grades. Can you see the overall grade now? I checked all the boxes. I don't get why it's not there. Huh? I checked the boxes. I haven't had a chance for me to have time to see Ms. Gallmeyer because our times don't mesh. But all right, here we go. So on this example here, it says find two z values, one positive, one negative, that are equivalent from the mean so that the area is in the two tails totals 5%, 2%, and 1%. So basically what you're trying to do, if we look at the 5% question here, I'm looking at totals, right? Is that what it said? So the area totals. Okay. So I'm looking for the area on both sides in which it will contain 5%. So what needs to be contained in each one of these percents? If these two have to total up to 5%, it needs to be 2.5% in each one. And now that we kind of understand probability in the area under the curve, this is something that's going to have a z-score of 0.0025 on both sides. So using your chart, locate what 0.0025 is. Right, did I do that right? Nope, my bad, sorry. 0.025. You have to move the decimal 2 places to the left, not 2 zeros. At 0.025? No. Oh, okay, yes, you're going to have a z-score of negative and a z-score that's positive. So go on the positive chart and find the positive z-score because the areas are going to be the same. Well, I take that back. No, it's not. So let's start. I got you. I see what you're talking about. Let's look up the z-score that's negative. So what's the z-score that's negative that gives me an area of 0.025? Okay, so negative 1.96 on this side, and to be equivalent on the other side, it will be a positive 1.96. An alternative of doing that, you could do 1 minus 0.025, and what would that give you? No. There it is, the 975. All right, so just to make sure we're correct, please locate 1.96 in your chart and verify that the area was 0.975. Good, so there you go. So you can do it this way and calculate it, or just know if you're looking for the same area on both sides, it's going to be the negative and positive version. So the z-scores here, that's going to give you a 5% equivalent on both tails, is negative 1.96 and 1.96. Does that make any sense? All right, so let's, what was the other one? 2%? Let's do 2%. So again, same concept, but my tail is going to be smaller. So I'm looking for a smaller tail. But if these have to add up to 2%, what's going to be the area on each side of them? 1%. If we convert this into a decimal appropriately, that's going to be 0.01 and 0.01 of an area. So just use your chart again and locate what standard deviation has an area of 0.01. None. Okay, so that when this happened, when this happens, we have to go locate. What do you mean? I was thinking we could do this in equation form because the standard deviation of z would be 0.0. Well, no, that would be the area. Should be using that equation. Okay, if z. Yeah, I'm gonna have to assume what's the closest one. I can't even think of a formula that would work. 0.009, which is what they got too as well. Yeah. Yeah. So this is what they got as well. I was just thinking there got to be an equation for it. So therefore, what's so that'd be negative though, right? So then on this side, it would be the what? Wait, I'm confused. So you don't have 0.01, but you have 0.099. Okay, okay. If it's 0.099, what's the z-score that goes with that? All right, negative 2.33. That would be the answer. And then over here would be the positive 2.33. Yeah, so it's just off by 0.0001. So since that's the closest one, we can go with this as an answer. Right. And the last one here is 1%. So again, same concept, but our tails, man, this is getting worse and worse. It's even smaller. What's going to be the percentage on both sides? 0.5, right? Yeah, 0.5% on both sides, which then I'm looking for an area of 0.005. Do I have something with an area of 0.005? We have multiple 0.005. Oh, I see. So which one do you want to go with? Let's do the average of the six then. Which one ever's in the middle? So like, okay, then what do we typically do with that? Okay, and what do you get? Just add a 5 in between. Oh yeah, but it has a number attached to it though. So it'll be like negative 2.55 or negative 3 or whatever there it is. Negative 3. Well, you're in negative 3s? Yep. I don't have the chart up right now. Let me look at your charts. Let's start off in the negative version. It's 0.005, correct? Okay, I see something right between it. I don't see something on 0.005. Oh, okay. Gotcha. And it's between negative 2.57 and negative 2.58, right? So then what's the number between those two numbers? There you go. And that's the number you would go with. I thought you said it was just the closest one. What was the other one? 0.01. There's 0.0. Oh, I see. But that one, yeah, that one you had to round up. That was way off. It's 2.1. What's the other one we're looking at? 0.05. Where's it? Where is it? Okay, I see. Okay. Same concept, right? So I wonder if they want us to round up or round down. What's the homework been telling you to do? Well, these are right in the middle. On the other one that we had at the 0.0, 0.01. All right. See on this one, 0.99 is closer to 0.01 than 0.0102 is. But over here, 0.5 is literally dead in the middle of 2.7 and 2.8. I think that's why I would argue 2.75, where we didn't do the same thing over here because this one was closer. Here's what the book says. I think the answer should be negative 2.75. Okay, this is what they argue. It says, in this case, choose the z value with the greater absolute value. So you would need to round up to the negative 2.8 instead of 2.75. So in that, when this happens again, we have a number in between, go with the higher number, the absolute value, the higher number. So this would be negative 2.8, and this would be positive 2.8. Absolute value. So even though negative 2.7 is the bigger number, the absolute highest number would be 2.8. Does that make sense? I don't know why. I would, in my opinion, on a test, if you would have told me the answer is 2.75, I would give you full credit. Well, actually, no, sorry, it's 5, right? 2.5. I bet put 5 there. But again, if you would have told me the answer was negative 2.575 and negative 2.578 I would have gave you full credit. I think that's a more accurate response. Right? So any questions then on 6.1 on using this chart? So again, the area of the curve is the same thing as the probability of getting a sample that will fall in between those standard deviations as well. And z-score again is just how many standard deviations you are from the mean. So we're all solid with this. Any questions that have come up on the homework? All right, then let's talk about 6.2 and that'll wrap up this week. So we're going to talk about applications of normal distribution. Basically, it's the same stuff, just word problems. So we're going to start off by finding probabilities for a normally distributed variable by transforming it into standard normal variable, basically just meaning that the mean is the 0, calculating everything from there. All right, so let's fill in these blanks here. All right, so the standard normal distribution curve can be used to solve many practical problems. Assume the variables presented here are all normally or approximately normally distributed. I will like to say it does look like my class isn't going to make it Lamar. So my tutorials will not change as of right now. They're going to make a decision tomorrow. I have 0 people that signed up for my class. This exact one, just in 8 weeks, face to face. I think it'd be better if it would have been an online option. I think more kids would have chose it, especially like in Polk County. Like it's just, I don't know. I think you have more. I think you have apt to have more people choose online. All right. First, we transform the original variable to a standard normal distribution variable by using this formula. The value, whatever your sample is, minus the mean divided by the standard deviation. It has it in words here and has it with the notation here, rounding the results to 2 decimal places. You know, that might be another thing why they kept it as the absolute value of 2.58, because that specific thing is rounding to 2 decimal places. Because what would 7.5, what would 7 become? innate anyway. So maybe that's why that's a rule. Sorry, my brain's still on that last problem. All right, so here's the steps on finding the area under a curve of a normal curve. So the first thing we'll do is draw a normal curve and shade the desired area. So I don't take off for the art part of it, but I make sure you're shading the right section of it. So like you've seen my bell curves, they're not that great. But if you just give me a bell curve and you shade the right area, I'm pretty happy. Just like when in pre-cal, as long as you graphed it in the right quadrant, I was pretty happy as well. So same concept here. So if I want you a graph on the left tail here and you end up graphing the entire thing, then obviously you're wrong. Does that make sense? So don't get too hung up on, oh, I got to practice my bell curves and stuff. All right. Then after that, we'll convert the x to z using the formula, which again was z equals the sample minus the mean divided by the standard deviation. You can write that in words too if you would like. Then after that, we're going to find the corresponding area using our table. We're going to kind of avoid the calculator software. The table looks pretty good. Any questions here so far? Right, so basically the same thing we're doing is just we're going to draw some graphs with this. So let's look at our first example in 6.2. Yeah. So our example 4 here is liters of blood. It says an adult has an average of 5.2 liters of blood. Assume the variable is normally distributed and has a standard deviation of 0.3. We're going to find the percentage of people who have more than 5.4 liters of blood in their system. So first, we're going to draw a normal curve and shade the desired area. So here we go. That's the first step to every one of them. After that, you want to put your mean, which in this case was 5.2, has a standard deviation of 0.3. So if this right here was one standard deviation and it's 0.3, what would this be? 5.5. All right. So that would be one standard deviation. And I'm trying to find out more than 5.4. So how should I shade this? Approximately to the right. So I'm going to slightly go on the outside of this 5.5. I'm going to write a 5.4 to tell the reader where I'm at, and then I'll shade this area. That is what I'm looking for. All right. So if you went to 5.4 and you shade it to the left, I would count this wrong. If you put 5.4, somewhere else on the left side or way over there to the right, then obviously that would be wrong as well. So illustrate where that first standard deviation or second, depending on what value you're looking for, is that, and then plug your number. Any clarifications on how I'm looking for graphs? All right, so it doesn't have to be too accurate there, but that's the numbers I want to see. All right, so then they use the formula here to find the z-score 5.4. So 5.4 is what they were looking for, minus 5.2 divided by the standard deviations. So we find out we're 0.67 standard deviations from the mean, which is why I'm not quite to that one standard deviation, because that's what this right here would be. This right here would be the mean as well. You don't have to illustrate those things, but just so you know. All right, then in step 3, it tells us then to look up the calculations. So to do this, I'm not going to scroll down, but if I'm looking to the right of this, what is the area at 0.67? So we found a standard deviation of 0.67, or sorry, we found a z-score of 0.67, which again just means how many standard deviations from the mean you are. So using our chart, we need to go to 0.67. What's the area? 0.7486. And because I'm looking to the right of this value, what am I going to do with this area? I'm going to subtract it from 1. And what do I get? Perfect. All right. Thus, we're looking for the percentage. So make sure you're specifically looking at what the question's asking for. This then converts into what? Okay. So we just calculated, given that this information is normally distributed, that 25.14% of our adults have 5.4 or more liters, right? So these are the guys you want to go after when you're going for blood donations. They're like, you have too much blood, you need to give it to us. Right? Does that make sense? Any questions there? Probably a freshman or something. All right, so any questions on that example? Yeah. All right, let's look at another example then. I did not. My hand doesn't turn that direction. So therefore, that percent there is what you would put. All right, example 5 here, we're looking at a monthly mortgage payment. So the average monthly mortgage payment, including principal and interest, is not $982. Maybe like before 2020. It's like a 2016 thing right there. Whew, I love that to be the average. Your average now is probably closer to 1,800. All right, so okay, if the standard deviation, I would love to know the year of this. All right, that's not the point. If the standard deviation is approximately 100, yes, go ahead. Yeah, that could be a study in the past. This is just copyrighted in 2018, but that's a good observation. Yeah, this was probably something that was copyrighted in 18, but they probably took something probably in 2008 or something, like a 10-year thing. Who knows? I don't know. But it doesn't matter with our math. It just, I don't know, not today's. If the standard deviation is approximately $180 and the mortgage payments are approximately normally distributed, find the probability that is random selected monthly payment is more than 1,000, more than 1,475, and then between 800 and 1,175. Right. So the first thing you got to do is calculate your z-score. Or sorry, it wants us to draw. I forgot it wants us to draw. So let's draw them and then we'll calculate it here. So this is how everything should look on every single one of them. Woo. 982. I don't know if it's getting worse. I think it's getting better. Maybe. 982. All right. This first one, I'm looking for more than 1,000. Well, first, let's look up our first standard deviation. So what would our first standard deviation calculate at? And how would I figure it out? So what is 982 plus 180? So 1162, perfect. And I'm looking for more than 1,000. So that needs to be a little to the left, right? Just like in the last example. So I'm going to put a little marker right here. And I'm going to go ahead and put 1,000. Doesn't have to be completely accurate. It could be closer to this one, just somewhere in that area. And if I'm looking for more than that, then I would shade what? To the right. Very good. All right. So same concept over here. This is 1162 for my first standard deviation, but I can see that 1475 is more than that. So what is 2 standard deviations away then? And how would I calculate it? Okay, so it's 1162 plus 180. Perfect. I can still see that what I'm looking for is more than that. So I need to go to 3 standard deviations. What's 180 plus all this? No, you're right. We're at 1,000. Perfect. All right. So then I can see 1475 is going to fall somewhere in between here. So I'm going to put a mark. It doesn't have to be completely accurate, but my 1475 should be between 2 and 3 standard deviations. And if I'm looking for more than that, I'm going to shade what direction? To the right. So there you go. That makes sense? Okay. So I'm looking at between 800 and 1150. Well, I know one standard deviation away was 1162. So that's going to help with the 1150, but I need to go backwards at the 800. So what's 982 minus 180? 802. So I can see with 802, my first mark will be like almost right dead on it. And then 1150 will be almost on this one as well. And if I'm looking between these two things, where do I need to shade? The middle. All right, so this is about as accurate as I want to see. Right, I want to see the standard deviations written, the mean, and then where your markers off and the appropriate shading. I don't care. Just shade it. It doesn't have to be a perfect shade either. Right. So that's what the first thing they wanted us to do was to draw this out. Now we can do the actual calculations, which in my opinion is a lot easier. I'm just never a big fan of drawing. I think they're cooler to draw them on an Excel sheet because they look pretty and accurate. Because you can put color in it. But yeah. Different kind of statistics course. Maybe if you take a statistics for science majors, you'll get more into it. Huh? One more time. So yeah, sign up in college. Yeah. That didn't hurt at all. Okay. Anyway, sorry. So let's calculate our z's. So our z score is just going to be the x value, which on part A, I need to go back. Was it 1,000? Right, thank you. So that's going to be 1,000 minus the mean, which was 982, divided by the standard deviation, which was 180. So the first thing you want to do is 100 minus 982, and then divide that by 180. And what do you get? Close. No. But you got the right idea of 18 divided by 180. 0.1. Yeah. Good. This one over here, same concept. It's going to be, was it 1475 minus 982 divided by 180. So again, do 1475 minus 982. And then you divide that by 180 already. So 2.72. So this tells us we're 0.1 standard deviation. So really our drawing should have been a lot closer to the mean than the first standard deviation. But I wouldn't count off for that as long as it's between. 2.72 is pretty accurate. We were pretty close between the 2 and the 3. And then this last one here, I need to find 2 of them because I got to find in between. So I got to find 800. That was the first one. 800 minus 982 divided by 180 is the score of it's round to 2 decimal places. Okay. And then our other Z score of, what was it? 1150. So what's 1150 minus 982? You already divided by 180. So 0.93. All right. So now that we have this, now we can find the appropriate area. I have my Z score 0.1, so I'm going to use my chart. What is the area at 0.1? So you would go to 0.10 on your chart. What is it? 0.5398. And if I was going to the right of it by doing a more than, what would I do with this area? So what's 1 minus this? .4602. And then what was the question? Are we looking for the percentage again? It says find the probability. Yeah, because probability can be rewritten as a decimal. So you're good with that. So even if you turn it into a decimal, I wouldn't take it off because probability can be written both ways. Now what's the area at 2.72? 9967. And I was looking for things that were more than that. So what am I going to do with this area? So what's 1 minus this? Close. Are y'all sure it's 9967? Oh, they went to 274. Are we sure we did this calculation correct? Let's check it. Just make sure. 1475 minus 982 by 180. All right. So then therefore at 2.74, the area would be all right. And then when we subtract that from 1, we should get 3.1. I will say that's going to matter. I know on the homework they'll count it wrong, and for me, I'm going to have to take a point off because of that calculation. I wouldn't count it all wrong, but I would take that 1 point off, right? So be as accurate as you can. Yeah, because if you would put 0.33 or 0.0033, I would have been like, where'd that come from? Because I would have said I got 0.031, and then I had to go, oh, you got 2.74. So then I would have took a point off, right? So make sure we check all our works. I would hate for y'all to lose point for something like this. All right, now we're going to come over here and we're going to find the area of both. It's always easier to find the area of the right side first. So what's the area 0.93? 8238 minus what's the area at negative 1.01? 0.1562. And when we subtract the 2, what do we get? Yep, perfect. So any questions on basically doing the same math? We're just giving it applied to a word problem with mortgages. All right. And in correlation here, that just means that you have a 46% chance of finding something that's more than 1,000. You have a 0.3% chance of finding something that's more than 1475. And here you have a 66.76% chance of finding something between 800 and 1150. Right? Back in 2008. That's what I'm going to go with. So any questions there? Maybe in the 90s. Maybe this is a 1990s thing. It's the 90s icon thing. Yeah. All right, let's look at objective 5. All right, so we're going to find the specific data values for given percentages using the standard normal distribution. Again, using the x minus mean divided by standard deviation. We're just going to be solving for the x this time. So you're going to be given different informations and then have to solve for the x. So you can either just stick with this, which is what I would prefer. But if you happen to want to find an equation of solving for x, what would the literal equation be of this? What would I have to do first? Let's say I don't know anything and I just want to get x by itself to develop a new equation. What would I do? Not mu, which is standard deviation. This is algebra. All right, so if you wanted an equation, there you go. Sigma times the z-score plus the mean will give you whatever the x value is. I personally don't learn it that way. I would just stick with the one formula, so this gives me one thing to memorize, and then I'd plug in what I know and then just solve for x that way. But whatever you need, this is what you would get right here. All right, so I think this has got pretty much already filled out for you on how to solve stuff like this. But it does give you the steps anyways, and we'll go through them. So draw a normal curve, shade the desired area that represents the probability or proportion or percentile that you were given. Find the z values corresponding to the desired areas from the table, calculator, or computer software. We'll stick with the table. We'll calculate the x value using the formula x equals z theta plus the mean. All right, so in this example, we're looking at the police academy qualifications. So to qualify for a police academy, candidates must score in the top 10% on a general abilities test. Assume the test scores are normally distributed and the test has a mean of 200 and a standard deviation of 20. We're going to find the lowest possible score to qualify. So we're going to draw a normal distribution curve and shade the right-hand 10% of the area. So here we go. Just like before, we were given the mean, what is it, 200? And it says to qualify, the candidates must score in the top 10%. All right. So I need to figure out what 10% of that normal curve would be. Now, to me, that's a little harder because I know this is 50% of the data. Oh, well, I guess you could kind of look at it as this. What's one standard deviation? Okay. And at one standard deviation, when I look back at my normal curve, what data is that usually represented as? Is it 67 or 68? Is it 68? Okay. So if this is 68%, what percent is left? You said 32, right? Okay, I thought you said 52 there for a second. So 32 to add up to 100. So on each side, that would be what? 16%, which is a little bit more than what I want for my 10%. So I'm going to go to a second standard deviation of 240. And if you recall, 2 standard deviations away was what percentage? I think it's 95. Yeah. I think the other one's 99.7. Huh? Yeah, the other one's 99.7%. All right. What's on both sides of these percents? 5%, which is less than what I want. So that tells me my area of my curve is going to be somewhere between 1 and 2 standard deviations. The issue is I don't know what that value is to find the minimum there. Right. So that's the kind of graph I want to see because you don't know the answer yet. Does that make sense on how I figured out where to shade? And I'm looking for the top 10%. So that means that it would be 10% and more. All right, we're all good with this? All right, so now we're going to calculate what that x value is. So the area of the curve is 0.1 shaded on the right side. So to find the table corresponding to an area of 0.9. Now, why am I using 0.9 and not 0.1? Exactly. So I would have to calculate which one has an area of 0.9 and then subtract it to get that 0.1. So look at our table and let's figure out what has a z-score of 0.9. Or sorry, has an area of 0.9. What z-score has an area of 0.9? There we go. Phew. No. Okay, but what's the z-score that corresponds to that? Remember, always look at the greater number if you're between two things. Okay. Is it between 1.28 and 1.29, or is it between 1.7 and 1.8?
What? 0.915 or 19.2.
Okay, so then
You should go with the greater one, no?
that's what the direction said. So that gives you 1.29. You got a good point there. The other one had the exact amount, and so we rounded. But this one's closer to what number? 1 point. I think I'm going to go with that direction. Just because this is 0.003 off, and that 0.00. Only when they're even. That's okay. So in this case, since that one's closer, we're gonna go that direction. Okay. No, that's what they got too, is 1.28. I was just trying to reason why we would choose it. So our z-score then is 1.28 because that one was closer to the 0.9 of an area. All right, then. So in step 3, I'm not going to scroll down. So in step 3, we're going to calculate that. You can either use the regular equation or use the one we just solved. So that would just be x equals the sigma, which was standard deviation, which is 20, times the z-score, which in this case is 1.28, plus the mean, which is 200. All right, so what is 20 times 1.28? And then add that to 200. What is it? I heard it. So 225.6. So that means to get into this police academy plus the 200, plus the 200. So that means to get into this academy, the person would have to make at least a 225.6 or higher to get qualified. And I don't know if they take decimals or not, so they might have to go up to 226 depending on their calculations. Any questions on that part? Let's do another example. There's no more? The seventh example, yes. So right there, you can see a score of 255 or 225.6 should be used for the cutoff. Anyone scoring 225.6 or more qualifies for the academy. Basically, in words there for you. All right, so this one is qualifying test score. So in order to qualify for a medical study, an applicant must have a systolic blood pressure in the 50% of the middle range. If the systolic blood pressure is normally distributed with a mean of 120 and a standard deviation of 4, find the upper and lower limits of the blood pressure a person must have in order to qualify for this study. So what's it say? So in order, applicant must have in the 50% of the middle range. So in order to qualify for a medical study, an applicant must have a systolic blood pressure in the 50% of the middle range. Find the upper and lower limits of the blood pressure a person must have in order. So mark the middle 50%. Oh, I get it. So it's the middle 50%. So we would need 25% on each side. So to draw this out, well, we about to leave? How long we got left? Oh, what do you mean 1 minute? Okay, we'll start this tomorrow then. So we'll wrap up 6-2 tomorrow, and then I'll give you time to work on your homework.